You may have two cars moving at the same speed. If they're not moving in the same direction, they don't have the same velocity. One car is moving to the right, the other car is moving to the left. They got the same speed, but they don't have the same direction. If that's the case, they don't have the same velocity. All right, so let's build up the mathematics for this one. All right, so velocity is going to be a combination of speed and direction. All right, so this needs to be turned up. So the direction is also going to matter. We have two cars, one moving to the right, the other moving to the left. And if they're not moving in the same direction, they're not going to have the same velocity. All right, so that's a given. All right, so this one is moving to the right, this one is moving to the left. And speed in this case is going to be 50 miles per hour. And once again, you got 50 miles per hour here, except it's moving in the opposite direction. If it's moving to the right, we'll take this to be a positive velocity. So this is going to be positive. If it's moving to the left, we'll take that to be a negative velocity. So this one is going to be negative. So we got positive velocities and we got negative velocities. All right, so what if we have an object moving in the downward direction? Again, this is moving at the same speed, so it's going to be 50 miles per hour. And if that's the case, let's just change the notation a little bit. Let's take the upward direction to be positive and the downward direction to be negative. All right, so it's moving in the downward direction, so this is going to be negative velocity. Notice that this one is a negative velocity, so is this one. So this is moving at 50 miles per hour, this is moving at 50 miles per hour, this one is negative, so is this one. Do they have the same velocity? The answer to that question is absolutely not. Why not? Because they're still not moving in the same direction. So what do we do if that's the case? Well, which means that we have to kind of change our notations a little bit more. All right, so let's take this to be the motion on the x direction. And let's take this to be the motion on the y direction. All right, so this is motion on the x direction, so we'll get to use a subscript. And this is motion on the y direction. So once again, we will get to use a subscript. So when we are dealing with velocity, direction matters. All right, so if we're dealing with velocity, the direction is going to matter. So what is velocity? Velocity is going to be a combination of speed and direction. So velocity is going to be a combination of speed and the direction of that motion. So the direction is going to matter when it comes to velocity. A good example of velocity is circular motion. Imagine that you have this object which is going to be moving in a circle, and it's going to be moving at constant speed. So you may have a car moving at 35 miles per hour. So I'm not going to change the speed, so the speed is going to remain constant. And this thing is going to keep on moving at the same speed. So it's going to be 35 miles per hour all the way along. Notice that the speed is constant, but the direction keeps on changing. All right, so in this case, the speed is constant, but the direction keeps on changing, which means that the velocity is going to keep on changing. So in circular motion, even if the speed is constant, because the direction keeps on changing, the velocity is going to keep on changing. All right, so in circular motion, even if the speed is constant, because the direction of motion keeps changing. Notice that it's going this way, and that way, because the direction of motion keeps changing. The velocity is going to keep on changing. That's what it means. All right. What's speed? Speed is how fast an object moves in space and in time. Proper unit for speed is meters per second. Average speed is measured distance over measured time. Instantaneous speed is the measured speed. So what's the difference between the average and the instantaneous speeds? Average speed is calculated, and instantaneous speed is measured. Average speed, measured distance over measured time, and the instantaneous speed is how fast an object is moving at a given point in time. So that's the speed which is measured. What's velocity? Velocity is a combination of speed and the direction of that speed. So what's the difference between speed and velocity? Speed is how fast, the velocity is also which direction. So speed tells you how fast the object is moving. Velocity is also going to tell you the direction of that motion. 60 miles per hour is your speed. 60 miles per hour up north is your velocity. All right, so in terms of problems. All right, so problem number 1 and problem number 2, these are the problems that we've done already. All right, so these are the problems that we've done already. Okay, so this is topic number 1. We completed topic number 1 right today. All right, so topic number 1 is the one that you will be testing on tomorrow. So there will be 10 multiple choice questions. And I think 1 or 2 of the multiple choice questions will be problems. And the problems are going to be like this in difficulty, problem number 1 and problem number 2. All right, so we've done those problems, which means that you have to review this material. Okay, so multiple choice section of the test, only 10 multiple choice questions, mostly conceptual and knowledge-based questions, and there may be 1 or 2 problems, multiple choice problems mixed into it. And then you have to review this stuff. All right, so this is going to be your test tomorrow. Okay, topic number 1. Okay, so let's back out of this one. Modules. Okay, so I want you guys to go into topic number 2. All right, so this is the one that we will finish up tomorrow, but we're going to start it today. Okay, so let's get started. So now we're going to be dealing with acceleration.
We crash it. We don't care about the damage. We care about the people. Our testing exceeds the government standards. Ford has more 5-star rated vehicles than any other car manufacturer. We go that extra mile to make sure that our cars are safe. I'm proud of that. We crash it. We don't care about the damage. We care about the people.
They don't care about the damage. They care about the shit. Now look at the damage.
We don't care about the damage. We care about. We crash it. We crash it. We don't care about the damage. We care about the people. We crash it. We don't crash it. We don't care about.
Yeah, this car is total. It's crash testing at 40 miles per hour, and this car is total 40 miles per hour. That's a fast parking lot speed. It's an average texting speed. You simply do not see the building coming, and you're done with that car. That car is gone. Why do they make these cars so crushable? Given the fact that they used to make cars almost virtually indestructible until late 1950s. Why did they stop making crushable cars? What's the purpose of it? Speaking of all cars, until 1950s, when I say these cars are virtually indestructible,
we had people pouring water on the tire as we went around in a circle to measure turning radius. We also had some large pendulums that we would pull cars onto, and by measuring the timing of the pendulum, we could determine the center of gravity of the vehicle. We did rollover testing of vehicles where we had an elevated ramp. And
all right, so you're driving by a parking lot. All of a sudden, you notice that a spot opens up. You can roll right in.
The car up the elevated ramp
on a hill
and let roll over a hill to measure structural integrity of the
Speaking of the structural integrity,
vehicle. We've got
not a single dent on this.
footage of
Not a single dent.
crash testing where the operator would stand on the running boards and put a brick on the
There's the operator, the driver is going to jump out of
accelerator, and just before he hit the wall, he jumped into the arms of a couple waiting fellas who caught him while the car turned into the wall.
So they went from these cars in 1950s. These
Safety issues came
crushable
to the fore in the 1950s with the arrival of faster, deadlier cars. As a result, crash testing kicked into gear with car makers putting their vehicles through a much wider range of tests.
All right, so why did they go from indestructible cars to crushable cars? What was the idea behind it? Okay, so I think you guys kind of know the answer, right? What's the answer? Safety.
We had
They decided to make these cars crushable. And when you make the cars crushable, they become safer. So how does that happen? When you make the cars crushable, how does that make it safer?
people pouring water on the tire as we went around in a circle to measure turning radius. We also had some large pendulums that we would pull cars onto, and by...
All right, so the crushable cars are safer, but the question is, how? Why not make the cars indestructible the way they used to make cars up until late 1950s and put the safety on the inside? We got the technology. So why not do it that way? All right, the reason why they make cars crushable is because of safety, and regarding safety, because the acceleration can kill. So the question is, how does acceleration kill? If you're exposed to 7 Gs or more acceleration, it can kill. So the question is, how does acceleration kill? 7 Gs, speaking of Gs, 1 G is the same as your own body weight. So what does it feel like to be exposed to 7 Gs? 7 times your own body weight. What does it feel like to be exposed to 10 Gs? 10 times your own body weight. So prolonged exposure to 7 or more Gs will kill you. That's what it means. When we say prolonged exposure, we mean up to a few minutes. So how does acceleration kill? Pilots in training, they're usually exposed to 7 to 12 Gs.
3, 2, 1, mark.
Here at the Vita Corporation Flight Simulation Lab in Warminster, Pennsylvania, Dr. James Winery and other researchers are using a centrifuge to reproduce high-speed flight conditions. They hope to better understand the effects that G-forces have on the human brain.
That's it. You're going to have to really strain now, Rob. He's really going to maneuver.
This video of Winery, recorded in 1985, dramatically illustrates what happens when pilots experience a blackout episode.
First thing that happens is blood flow begins to be reduced to the head. So you begin to develop a tunnel vision. The next thing that...
All right, so at this point, he starts to pass out. Just before you pass out, it feels like you're having an out-of-body experience. when you're exposed to 7 Gs, you're thinking that you're feeling 7 times heavier, which means that you're thinking that it's going to crush you to death. In reality, no. The way you will die is going to be one of the most pleasant experiences ever. It'll feel like you're having an out-of-body experience. That's exactly where he's at right now. Look at the eyes. Eyes are open. The mouth is.
See is loss of motor control, loss of sensory
He looks dead at this point.
input, complete
Then he
loss of
passes
consciousness.
out. At this point, they will stop the experiment. This guy is a medical doctor. He wanted to know exactly what it would feel like to experience 7 Gs. And then he found out. Why did he pass out? What happens when at 7 Gs? Well, it's related to what happens whenever you drive. Whenever you accelerate, what happens to your body? The car accelerates in forward direction, and you feel a push in the opposite direction of the acceleration of the car into the seat. And then you put the brakes on, and then you go in the forward direction, in the opposite direction of the acceleration of the vehicle, right? So, do you notice that your body inside the car is always going to move in the opposite direction of the acceleration of the vehicle? So the objects inside, unstrapped objects, will always move in the opposite direction of the acceleration of the vehicle. Those of you guys who are religious, watch Jesus accelerate. Notice that Jesus is having a hard time keeping up with his cross. The acceleration could be a religious experience. What's the difference between a BMW and a Ford Tempo? Ford Tempo, for those of you guys who don't know, it's a real old car, right? It's about 30 or 40 years old. If anyone is selling it, you can't probably find one under $100. BMW, as you all know, it's a really expensive car. The reason why it's expensive is because it can go from 0 to 60 miles per hour within less than 4 seconds. BMW, on the other hand, is going to take about 2, 3, 4 minutes down a hill. Both of them are going to be moving at 60 miles per hour at some point, except one of them gets there much sooner. That's what you pay for whenever you buy an expensive car. You pay for the acceleration. All right, so what's the best answer in this case? So we got the unstrapped objects in an accelerating body, like a car. They will move in the opposite direction of the acceleration of the vehicle. So that's going to be the best answer. They will all move in the opposite direction of the acceleration of the vehicle. All right, so let's take notes. What's acceleration? In this case, speeding up is acceleration, so it's slowing down. Question number 2, ignore. We'll get back to it. Question number 3, what's the G? G is the same as your own body weight. 1 G is 1 time your own body weight. 10 Gs, 10 times your own body weight. Question number 4, what direction do unstrapped objects move while the car is accelerating? Unstrapped objects will move in the opposite direction of the acceleration of the car. Question number 5, if you're speeding up, are you accelerating? The answer to that question is yes, because speeding up is acceleration. How about slowing down? Slowing down is also acceleration. How do we know that speeding up is acceleration? We know that speeding up is acceleration because the unstrapped objects will move in the opposite direction of the acceleration of the vehicle. We also know that slowing down is acceleration because, once again, the unstrapped objects will move in the opposite direction of the acceleration of the vehicle when you're slowing down. So they will move in the forward direction. All right. So why did this guy end up passing out the 7 Gs? What happened in his body? What happened in his body was straightforward. Imagine that I'm driving my Swift Ford Tempo in this direction at 7 Gs. What happens to my body? My body is going to experience a push in the opposite direction of the acceleration of the vehicle, right? So what happens to the blood in my body? It's going to get pushed in the opposite direction of the acceleration of the vehicle. So what happens to the blood in my head, in my brain? Once again, the blood is going to pull in the opposite direction of the acceleration of the vehicle. So the blood is going to start to move towards the back of my head, back of my brain. So what happens to the frontal lobes? Lack of blood, lack of oxygen, eventually you will pass out. So that's what happened to the guy. But the problem is, this guy wasn't speeding up. He wasn't slowing down, or he was just moving at a constant speed. He was inside a centrifuge. He was moving at a constant speed, up at about 60 miles per hour. So how did they experience acceleration without speeding up or slowing down? How did they induce acceleration at a constant speed? How's that possible? Well, which means that we may have to actually expand our definition of acceleration. So far, here's our definition. If a car is speeding up, the unstrapped object moves in the opposite direction. In this case, the pendulum is going to move in the opposite direction, in the backward direction of the motion. When you put the brakes on, pendulum moves in the forward direction, which means that the acceleration will be in the backward direction. So speeding up is acceleration, so it's slowing down. But what happens when you're in a curve? Look at the pendulum. Pendulum moves away from the center of the circle, in the opposite direction of the acceleration. All right, so the circular motion is also acceleration. This guy was on an upright centrifuge, which means that he was sitting up here, his head in the upward direction, along the Z direction, with his back against it. The acceleration was directed towards the center of the circle, which means that the blood was being pushed away from the center of the circle, radially away towards the back of the center. And that's the reason why he passed out. Now, this gives us additional definition of an acceleration. So is acceleration, so it's slowing down, so it's changing direction. All right, so what is acceleration in this case? So it's going to be speeding up, slowing down, and changing direction. Speeding up, slowing down, and changing direction. So speeding up is acceleration, slowing down is acceleration. Even if you're moving at a constant speed, if you're changing direction, if your direction is changing, that's also acceleration. So you may be moving at a constant speed. If the direction is changing, that's also acceleration, which means that you're still accelerating.